Let's take a look at these two functions and how the derivatives might look like. So by looking at the first one, we see an exponential function. It's composed with 3x, so it's not just e to the x. Here there's also a composition of cosine x and 4x. Cosine x is the trigonometric function. And we have a product. So these are hints for many things, like the product rule, the derivative of cosine, the derivative of sine, and the derivative of the exponential function, and the derivative of the composite function, which I have all here as guidelines. Not in the same order that I've mentioned, but some permutation of it. So we always start by looking at the expression itself, and here we have a product. So the derivative will be obtained by fixing one of the factors and taking the derivative of the other, then doing the opposite operation, and then finally adding the result all together. So I would do like this. There's going to be a plus sign here. Give myself a little bit more space. So what's going on? Let's say I'll fix e to the 3x and just leave sine of 4x as it is. But then I will now leave e to the 3x and take the derivative of sine of 4x. So precisely this is the derivative. And I can do the exact same thing for the other expression. So it's a product of two terms. I take the derivative of e to the 3x, and then I fix cosine of 4x, and then I do the opposite thing. So I fix e to the 3x and I take the derivative of cosine of 4x. So there are three things we need to compute. Number one, the derivative of e to the 3x. And for that I can use number 2 and number 5. The first thing is, this is of course a composition of two functions which are e to the x, but you plug inside of this e to the x, you plug in 3x. So these are my two composite functions, and I take the derivative of this. So in that case, we will take the derivative of the outer function, which is e to the x, whose derivative is also e to the x. So this is equal to e to the x, composed with the inside function, which is still 3x. But then you still need to multiply by the derivative of the inside function, which is 3x prime. Okay, so this is getting a bit simpler. I know how to do this part. I just plug in 3x into e to the x. That's literally what I wrote here. So this is just e to the 3x. And then I multiply by the derivative of 3x. And the derivative is the slope. So the slope of a line, of the line 3x, is 3. So my derivative is actually 3 times e to the 3x. That's the first derivative we need to compute. The second one is the cosine function. Not just the cosine, but it's the cosine of 4x. Maybe I'll give it a blue color just to add some something new. So here there are two things. This is of course the composition of cosine of x and 4x. I think that is clear. You just plug in 4x inside of x, you get 4x. So we apply the chain rule again, which gives you the derivative of cosine of x composed with 4x, but then do not forget to multiply by the derivative of 4x, which is the inside function. Now this is not too difficult. The derivative of 4x is 4. So I'll just put it on the left here. And this is what we still need to find out. What is the derivative of cosine of x? It's the negative sign. So I can replace cosine of x and I can write negative sine of x. Of course, this is the function. So we're multiplying. I hope it's okay if I take the power outside. And if you want to plug in 4x inside of sine x, you just get minus 4 times sine of 4x. So the derivative of this is not negative sine 4x. It's negative 4 sine 4x. It's also not a negative 4 sine x. So these are two common mistakes. You have to have the 4 here outside, and you have to have it inside, because the angle does not really change at all, if that makes sense. So negative 4 sine of 4x, that's the derivative. As for the other side, we still need to compute one more derivative, which is the derivative of sine of 4x. Now again, this is not special. So it's a composition of two functions. I'm just repeating the same thing. Sine of x composed with 4x. And then the derivative is going to be the derivative of sine x composed with the inside function. And then you multiply by the derivative of the inside function. Never forget this. And then again, this is just 4, because the slope of a line 4x is 4. And then we're composing the derivative of sine of x, which is cosine of x. So this is what's happening. This derivative of sine of x is cosine of x. And we're composing it with 4x. So it just gives us 4 cosine 4x. So it's not just 4 cosine x. It's not just cosine of 4x. It's 4 cosine of 4x. And if we plug this in, we plug all of these three things in, we get the answer. At least for the sine one, you can notice that the derivative of e to the 3x is 3e to the 3x. Okay, I still need to write down the solution. Maybe I'll call this y1, and I'll call this y2. So y1 would be equal to, just by plugging in, so this will be 3e to the 3x here, times cosine of 4x, plus e to the 3x times the derivative of this cosine 4x. But the derivative of this cosine 4x is this. It's minus 4 sine of 4x. So I'll just put the minus there. Maybe I'll put the 4 as well. And then I can take e to the 3x as a common factor, as a matter of fact. Then you have 4 sine of 4x being taken away from 3 cosine of 4x. So that's what's really happening here. Don't forget to include the bracket. As for the second one, you also get the factor of e to the 3x, because this is e to the 3x and this is e to the 3x, but this comes with a 3. So don't forget that this comes with a 3. So you get 3 times sine of 4x. But here the derivative of sine 4x is 4 cosine of 4x. So this is what we are adding here. And these are the two derivatives. This is how you do it from scratch. So you start from nothing and you build your way up. Now I want to mention something, which is particularly a disclaimer. The problems should not take this long from you. If you need to take the derivative, it should not take this long. I break everything down into the simplest of pieces, so it takes me 12 minutes. But if you are doing this, then it should not take you 12 minutes. It should take you much less. And you do not need to show all of this work. That is a very important point to make. And that is it.